tonight's lesson is kind of an extension on Monday's lesson, kind of an extension on JavaScript 3, in that we're still talking about classes. We're still talking about inheritance. We're still talking about the prototype. We're still talking about everything we did, not everything, well, everything we did on Monday, just in an ES6 way of doing it. Tonight is going to be more like a deeper dive and a Q&A session for you, because there's not a whole lot of super brand new concepts we're going to go over tonight. It's more of just an extension of what we did on Monday. So that being said, get questions ready. I'd like a lot of questions tonight, and we're going to go over ES6 classes. All right, so if we remember from Monday and from last night and working on JavaScript 3, we can create these objects that have some extended functionality to them. And we can do that by creating a function, giving it a name. So let's say, we're going to say fruit this time. Right? This is just a function right now, right? What do we notice that's different about this function? Okay, right off the bat, just to review, the capital F, exactly. Capital F, and it's not an arrow function right now. There was a really cool Wes Bos article on JavaScript 3 about when not to use arrow functions and why we don't. Real quick, why don't we use arrow functions sometimes? If anyone can throw it out there. Binding, yep, it automatically binds. And sometimes we don't want that. Right now we don't. Okay, oop, I want to make this bigger too, so we can see. All right. So yeah, we're not going to use arrow functions here because it's binding. It auto binds this. And we want to level the playing field. What we know about this stands right now. When you use arrows, it makes things a little bit trickier. All right, so we know that just by convention, when we have a capital F, what does that mean? What does that mean we're allowed to use? It's a class, and we can use a certain keyword. New. So those of you that said this, you're allowed to use this on any object. It doesn't have to be a class. You can use this on any object, any function, as long as there's context for this, right? But for the capital letter, we know that we can use new. So let's say banana. We can say new fruit, right? Awesome. And what does the new keyword do for us inside of this function? Creates a copy, makes a new this, creates a new object, creates a new instance of this. Exactly. So you're all right. You're all correct. It creates a new instance of this. And what is this if we use new? That's pretty easy. Never mind. This binding is the new instance, right? So we can always determine that banana is going to be, if we say banana dot something, because we use the new binding, it's going to refer to banana. All right. So let's go. Let's add let's just say type. And what else would a fruit have? Geographical area. I hope I spelled that right. Probably not. Okay, so since we know that the new does this, essentially, geo area. That's a way better way of doing it. Geo area. And then it also does this at the end. We know that we can now just refer to this, okay? And what is this referring to? It's referring to this exact instance of fruit, Okay, it's going to be a new instance of fruit, and it's this instance. So then we can just say, type probably isn't. Type is probably a keyword somewhere, and then we can say this dot geo area equals geo area. Okay, and so then we can go in here and what's the type of banana? I mean, we'll just say banana. Kind. And then geographical area, tropical. All right. So now we have, when I console log banana, we're going to get that it's a fruit, and it's going to have a type and a geographical area, right? So in this case, this Cavendish is a word. That's a type of banana. I like that. This is essentially using a class as an object template, right? It's just creating an object template. It's, we can create const. Give me a fruit that's somewhere not in a tropical area. So any fruit, apple. Apple, new fruit. We're going to say apple. And then what's geographical area of an apple? Give me a geographical area for apple. Washington. I'm sure there's some sort of, we'll just say Washington just for right now. And yeah, so we can see that we are just using it as an object template, right? It really starts to get powerful when we start to use our prototype. And so we're going to say prototype dot needs heat, and we'll make this a function, and then we'll say if this dot geo area equals tropical, return true, otherwise return false. Okay, so remember, we could have done this and if we did this, what is the downside of not using the prototype? What's our big downside? Exactly. Very memory intensive, right? I mean, not really memory intensive for creating a banana and an apple, but if we're creating every single fruit that is on planet Earth, then yeah, it's going to get pretty memory intensive. And if we have maybe not needs heat, but needs cold or something to that effect, then and you start having more and more and more of these methods on the class itself, then yeah, now you're creating thousands and thousands of these memory intensive functions every single time you run your program. So to get around that, we use the prototype, okay? And now we can see that we run it. Nothing has changed. Nothing looks like it's changed here, but now we can say needs heat, run it, needs heat, run it. And look at that, we're getting a true and a false, okay? And so we need to really understand that this needs heat lives on the fruit prototype, but that this is going to refer to each instantiation of that class, okay? It's going to refer to, if I say banana.needs heat, then this refers to banana. If I say apple.needs heat, then this refers to apple, okay? Even if it's on the prototype. That's where this starts to get really tricky, is when it lives on the prototype and it's not necessarily part of the main constructor function. Levi, you'll see both. Okay. This is dynamic when it comes to using the new keyword. And this always depends on the context. This keyword always depends on the context. And since we remember, what's our 4 types of new, or our 4 types of this context? I see Christopher said implicit. Let's see, we have new, we have window, and we have explicit. Which is this which is the current example an example of? The current example is an example of the new binding, okay? Because we are using the new keyword. All right? Implicit binding is very simple. Okay, that's implicit binding right there. We're not using the new keyword. Our method is inline in our object. You know, this context is very, very straightforward. It's object or whatever this is, Dan OJ, right? It's really kind of straightforward, right? We can see where it is. Okay, and the new keyword is a version of the implicit, but we know when we use new, it's going to create a new object. It's going to create a new class that is going to have the context of that individual instance of that class. All right. What's explicit binding? We'll use explicit binding in just a moment. Apply, call, and bind. Yep. So we are explicitly binding the context to the function. Okay, that's explicit binding. So now that we have been able to create a class. This is called our constructor right here. Our constructor is how we create the class, right? We say new constructor, right? And it goes in and does a lot of cool stuff for us. And then we can add some stuff to the prototype. Let's move on. Let's say now that we realize that apple is not just one fruit, but tens of thousands of subspecies of apples, right? And we thought, okay, well, an apple is a fruit. Not all fruit is an apple, but there's also a ton of different apples out there. So we can probably make our own apple class, right? But we want to make sure that we understand that it's still a fruit. Okay. So what would an apple be? Variety? What variety of the apple it is? Oh yeah, I know a lot of apples, but I'm just trying to think of what some cool things we would want on apple is. Color. There we go. That's a good one. Okay. All right. So we want to say this dot variety equals variety. All right. So we're setting a key on that object with whatever's coming back here. I want to make sure that this line is clear to you all as well. That we're setting a key on the class called variety, and we're going to set it to whatever variety equals, whatever we put in there. All right, and we're going to say this dot color equals color. Okay, so we already know how this works, right? We know that it's creating a new this context and it's returning that context. And then let's go and create a new apple. So instead of fruit, we're going to say apple. And we're going to say Honeycrisp And then color is orange, red. All right. So now let's do this. Oh, well, we're getting the apple.needsHeat is not a function. Why are we getting that? Because Apple has no idea that fruit even exists right now. We're not doing anything. Essentially, this is living in its own little world right here. It doesn't have any prototype on it. It has nothing, right? So what do we need to do? First things first, what do we need to do? Before we do the prototype. We need to inherit all of the key value pairs, all of the properties of fruit into the apple. We're inheriting, okay? We are creating a child of the fruit class. And how do we do that? Ooh, Jorge, you almost had it. Fruit.call. And what is the first and sometimes only argument that call, apply, and bind take? Not just this, but what is it? Context. Exactly. So it's the context. It's the context we want to give this. Okay? And remember, what are we doing up here? So if I say this right here, that's actually putting that context into the fruit constructor, okay? That's what it's doing. It's not just, this isn't just an arbitrary thing here. We're putting this object into it, right? And saying, call fruit with the context of this. So now, fruit isn't doing this part anymore, okay? It's saying, okay, I already have context. I know exactly what to do with this. Just add these two items to that object and then give it back, and then we can add a couple more items to that object, right? Yeah, there are other ways to give in context. We could do something like that. So const another object, and then we can put another object in here, and it'll mess everything up, but now it's getting a different context, right? Oh. And now another object is going to have those properties on it, and this won't, this won't, right? So we're passing this as context. And then what else are we going to give our call? Christopher, how does fruit know to return this without the return keyword? We are using new, and when we call that class in here, JavaScript does that automatically, and the new keyword on Apple does that automatically for us as well. So there's a little bit of magic in here with that new keyword. It's doing a lot of stuff. And the new keyword was actually pretty modern and pretty new. We had to do it a completely different way up until, I want to say 6 years ago. Yeah, so what else is fruit call going to take? What is the next item? What is the next argument that call takes after the context? Remember, what's the difference between call and apply? What does call do? Call takes comma separated values, right? And what does apply do? What does apply take? Apply takes an array. Exactly. Okay. So what does fruit expect to get when you call it? Let's look at the fruit constructor here. What does it expect to get when you call it? It expects to get a type and a geo area. So we need to put that in here, right? So since we know that every single time we call apple, it's going to be an apple, let's just do that. Apple. And man, I saw that like northern equatorial. I forgot what you just put. Post it back up there again so I can see it. Northern equatorial, something like that. Oh, I think it's not EC, it's EQ. Something like that. Is that what the the official region for an apple is? Equatorial. All right. Okay, so now let's do this. All right, let's just console log what this is halfway through creating this apple. Halfway through creating the apple, look at that. As a type of apple and a geographic area of northern equatorial. All right, that's all it has. Now let's go. And let's do this, actually. All right, we're going to console log this 3 times. When we first start it, after we call fruit, and right before it returns. Let's look at what we have. At the beginning, we have, it's an apple, right? It's a new instance of apple, and it's empty. Okay? Halfway through, this is after we have called fruit, that instance of apple now has a type of apple on it, and a geo area of northern equatorial on it. And at the end, after we've said this dot variety and this dot color, now we have all 4 of those on it. Okay. Does that make more sense now? So you can watch that progress happening the entire way through that constructor function. All right. And now we end up with whatever this is. Remember, that's what it does, right? The very end, as soon as, if we call new, it returns this. So we're getting this back, right? And we can do that by saying those are the exact same objects right there. An instance of apple, type apple, geo area, northern equatorial, variety Honeycrisp, color orange red. The same exact thing we're getting there. All right. Any questions on that right now? And using fruit.call, calling the parent and inheriting that stuff. Michael, that's a great thing to bring up. So what if we just said Apple stuff, and we expected Apple stuff to be an object? Well, we can pass it a single object. We can give it a variety and a color. And this is how you'll see it happen a lot. And then in here, we're going to go Apple stuff dot variety. That's how we access it, right? And Apple stuff dot color. All we're doing is just passing an object in with a couple of key value pairs on it, and we're turning that into a class. Oliver, Apple is not considered an array. Apple is an object. It's actually a class instantiation, but it's an object. In this case, you wouldn't, but oftentimes you'll see that Apple stuff is going to be all of this, right? So that might be the case where we're going to say Apple stuff is going to get everything, So when we would do that, what else do we have? Geo area. Oh, wait. Northern equatorial, right? And then that would run the same thing. Let's see. We would need to change that too. Dot type. All we're doing is passing objects around now. Same thing. Now it's the same exact thing we've just did. Okay? But I really want to focus on that. That's just passing arguments in as objects. Okay? At the end, the instance of Apple has been made. As soon as you say new Apple, it creates a new instance of Apple. And this is right before it returns. So all of that has already been done for us. Okay? Yep, I can do that, Manny. When you are dealing with, when you are creating child classes that are inheriting from a parent, you will always say this. That's when you would use that. .call, remember, we went over this on Monday when we had functions that we called using a different context. We used a different context other than this. But when we're creating a child inheriting from a parent, we're always going to use this. We just have to realize what this is, right? And remember, that's what it is. It's a new instance of Apple, and it's empty. That's all it is. I'm not sure I follow you, Jeffrey. Correct, Vinky. All right. We're going to go over Apply JavaScript next week. So if you're talking about anything we display on HTML or CSS, we'll talk about all that next week. We just want to understand classes now. No, you cannot have multiple parents. Okay? You can have a grandparent. So if, in your case, Michael said, can a child have multiple parents? A Honeycrisp, both a fruit and a food. So food would be the grandparent, fruit would be the parent, and apple would be the child. Okay, and it can inherit all the way down that line, right? We can have a third, fourth, fifth, sixth, 100th child. Yep. I would maybe switch BMW and SUV, maybe. So it'd be vehicle, SUV, BMW. Yeah, that absolutely matters. Great. Thanks for bringing that up. Thank you. If I called that right there, who can think of something that this would possibly mess up? Any ideas? If I had the fruit.call this apple stuff, it'll always be defined. This will be defined. So what if I said, and remember when we talked about our prototype, what if I said, for some reason, I did this. Tree fruit or something. didn't. Oh yeah, there we go. So now I wanted to override something in fruit. I can override anything in the parent, okay? But fruit's going to come back in and override that. So now the type isn't going to be what I thought it was going to be. It's going to be apple, okay? So you always want to put the inheritance at the top, just so you can inherit all of those properties, and then you can go through and change them if you want, all right? So you always want to inherit first. Michael, if a parent has a child and the child inherits everything from the parent, does a grandchild automatically inherit everything from both, as long as you call the child constructor? Yes. As long as you have it set up like this, okay, and then, if we had a function red apples, and then we had apple stuff, etc., and we said apple.call this apple stuff, and I said some other stuff, this dot sweet true. Red apples will get everything from apple, and it will get everything from fruit. Okay? Yes, so it will. All right. One last thing before we take a quick break, a bit more of review, is our prototype, right? So we still don't have apple.needs heat, okay? We don't have it yet. What do we have to do now? We're calling the fruit. What is the fruit doing? What is calling the fruit with this context doing? Calling fruit is going to add those properties from the constructor. It is not going to copy the prototype. The prototype lives in one place. So how do we link those prototypes together? We use object.create, so let's go through it. So it'll give me the before the assignment operator, apple.prototype. So now we are setting our apple, before we do this, has a prototype. This might not. I want to get rid of this stuff now that we know it. All right. Let's console log apple.prototype. Look at that. That's our prototype right now. We already have it. Okay. But we need to now fill it with our fruit.prototype. And if I do this, we're going to run into some issues that I don't really want to get into right now, but they're reference errors. And how do we create a copy and then link those prototypes together? You all had it before. It's object.create. You guys are going to love today, by the way. Object.create. So object.create takes a copy of it, and it links them together. So now I can call apple.needs heat and get false from it. Yep. All right. The new keyword also creates an yes, it does. It does it the first time it's the apple's called. It does it the first time. Because remember, that prototype is shared between every single instance of Apple. All right. So now we have a parent, which is fruit, and we have a prototype method on that parent. We're creating a child inheriting all of that awesome stuff from the parent, and then also inheriting the prototype. Okay. And now we can use the prototype, and now we can create our own stuff. Apple dot is good in pie. Return true. All right. Oh no. Oh, that's why I messed that one up. Prototype. And we get true. Boom. Luis, great question. Why can't we use this dot prototype inside the object? Let's look at it. Undefined, right? Because the prototype isn't created inside of the object. It's created outside of the object. It's created when we called new that first time, okay? Exactly. Prototypes have one space, one area in memory that they exist. And it's created when the new keyword is created. And so we don't have access to this dot prototype in the constructor. The prototype lives outside of the constructor. I don't follow, Mehdi. What if you want to assign the same prototype to all the objects? The same prototype is assigned to all of the objects. Object that creates pretty quick way of doing it. If you are curious as to how we used to do it, look up the classical instantiation, pseudo-classical instantiation, object instantiation, and there is one more that we used to use. Pseudo-classical is leaps and bounds amazing compared to the other ways we used to do. All right. So we know we can now, and then if we go right here, if I say good in pie, what if I say banana dot is good in pie? What's going to happen now? Yeah, banana doesn't have access to that, right? Remember, the parents don't know anything about their children. They're horrible parents. They don't know anything about their children. They don't know that their children even exist, okay? So you have to remember that. If I were to create a banana class that was also a fruit, banana would have no idea apple existed, all right? Apple knows that fruit exists, but fruit doesn't know apple exists. All right? So keep that in mind when you're doing this stuff as well. Okay, parents don't know their children. They don't even know that their children exist, period. All right, any more questions on this right now? I know there's probably a lot of things going on through your heads. Levi, when linking a child to a parent using, it's not child.call, it's parent.call, right? And the parent.call, remember, what happens if we call something? We're in dot call. What are the arguments that dot call needs? It needs the context, right? So we're going to give it the context of Dan so that when it reaches this, it knows what context it is. And then we need every parameter that says hi to friend is going to expect. right? So we need to say Stefan, right? We need to get rid of that. And then Dan says hi to Stefan. Okay. So every time we use .call, if there was 4 friends on here, friend 1, friend 2, we would need to put all of those in our .call. The same as when we do .call right here. Right now, fruit is going to expect a fruit stuff object. So we're going to give it 1. If it was expecting 3, we would give it 3 comma separated if we use call, or an array of 3 items if we used apply. If I console logged Apple down here, all right, let's see. I don't want to actually change that. So that's actually awful naming because there's 2 apples, even though so apple 1 is a type of fruit, right? This might be replit as well, so let's go into our console here. And look at that. So it's a replit thing. If you want to check the instance of what your item is, you can do this. Apple 1 instance of apple. And it'll tell you true or false. Okay? Yeah, so that's the constructor. So that's resetting the constructor. JavaScript will usually do that for you, modern JavaScript. But that's Replit being weird on that. So you can set the constructor to whatever you want it to now as well. All right, let's take a break. We're going to come back in here and we're going to be very happy and excited. All right, so let's come back in 6 minutes. We'll come back at 54 after. All right, everybody, come on back, and we will continue our journey through classes. And I'm saving all of this code in a gist, like I did for the last lesson, and I'll share that with you at the end of class tonight. I'm going to get rid of this stuff down here because that was not necessarily part of our, let's get rid of that. We got banana, we can do a banana, and a where do we say? There we go. I do want to okay. Pi. Let me go through. I'm going to switch this one to our. All right. Like I said, don't worry about this. I have saved all this stuff for us already. We're going to go through ES6 classes now. So with ES6 2015, we were given the amazing keyword class. Okay. And remember, how is it that we knew before that something was a class that could use the new keyword? How is it that we knew before? There was a single capital letter that was completely unenforced, right? The capital letter was just like the JavaScript community's way of being like, we've got to do something. There's no way to enforce this. You were seeing classes that were lowercase. You were seeing classes that were all uppercase. It was kind of all over the place. That was the only way we knew, right? We're like, okay, we know if we see a capital letter, a variable starting with a capital letter, that we can use the new keyword. 2006 or 2015 gave us the class keyword. And also ES6, ES 2015 as it was called back then, was a, they were trying to be a lot more like other object-oriented languages. So if you've ever used Java or C# or any other object-oriented language, you're used to the class keyword. How do you tell anyone that what you have is a class? Yes, a class, right? It's pretty easy. JavaScript did fake classes, but we now have the class keyword, and the class keyword gives us some really, really cool stuff. So yeah, those of you that are familiar with other languages, they're not real classes. But those of you that aren't, don't worry about it. So ES6, how do we use real classes? Well, we take the function word off, okay? And instead of saying function, we say class. Wow, that was pretty simple, but we're not done there. So there's a bit of syntax that goes along with an ES6 class. First is that an ES6 class is only the class keyword, the name of the class, and a curly bracket. Okay. The other side is a closing curly bracket. This is now an ES6 class. All right. Almost. So you might be asking yourself, well, if I say new fruit, how is it going to know to put all this stuff in here? Let's talk about it a little bit more. Remember when we said function fruit like this, what did we call this type of class? What did we call this type of function? If anyone remembers. Called it a constructor. Yep. So we called this a constructor. So if we use the class keyword, we have to give it a constructor. Okay. We have to give it a function to call when the new keyword is used, right? And so how do we do that? We use the word constructor right inside of it like this, okay? This syntax might be a little weird at first, but you'll get very used to it. Inside of this constructor, since this is now the constructor, instead of this, we can essentially do this. Okay. So now what happens if I'm just going to comment all of this stuff out. I'm going to comment this out. All of this stuff right now. We'll come back to it. Console log.banana. What do you think is going to console log? I mean, the exact same thing, right? Fruit. Type. Oh yeah, because we gave it that object. Sorry about that. Geo area was a little bit different. All right. So now we have it, right? Type banana, geo area tropical. No different, right? It's absolutely no different than if I had done this. Let's come down here. Same exact thing. So what this is doing right here is the same exact thing as what this is doing. Okay, it's just now a little bit more clear that it's actually a class. All right. Any questions on that right now? So remember, this constructor is doing the same exact thing. Right? It's doing that whole thing, the same exact thing that our old pseudo-classical inheritance way was doing it. Seems like we're adding an extra step. We're going to take one step forward and 2 steps, or we're going to take 1 step back and 2 steps forward, Griffin. You still do new fruit like you did before. Feels like we're writing it twice. All right. Let's get to our prototype. So we have that fruit, right? We have that constructor in there now. We're using the class keyword, so we know it's a class. And then just to follow convention, that's always been, we're going to call fruit with a capital F. Our constructor is going to do the same exact thing that this did, our constructor did before, right? So now what if we say needs heat, right? So I've come in here, I've accessed the prototype, I've added a method called needs heat, and we get true, right? Nothing's really changed. This is where the class stuff really starts to get cool, okay? Now instead of doing it after, the constructor within the class, I can say needs heat. I can give it a function. Oh, I gotta delete some stuff out of here. And I can just write that function right into the class. Okay. So what this is doing now is this is adding needs heat to the fruit prototype for us automatically. And it's still returning true. Okay, so you don't write that. You don't write that. All right. You just write the name of the method. And then, so essentially what's happening under the covers is it's doing needs heat, etc., right? It's doing all of this for us. You just write the name of the method and you give it the function signature, okay? Within the class. Everything now stays within the class. Everything. All right. So look at that. So now, oops, I'm going to copy that again. I'm going to do a fruit.proto. Now I'm going to delete it. I'm going to get rid of all this stuff now. Look at that. I can add however many I want. I don't comma separate them. Okay. I don't need to do this, right? I just write the name of it, and I write that function signature on it. I can say like, is a fruit. Return true. And now I can just say, instead of needs heat, is a fruit. And now we automatically have 2 items on the prototype. Okay? It's outside of the constructor, like before, but it's within that class, those class brackets there. The methods are being written on the prototype. Yep. Oliver, I like it. This is what Les was to vanilla CSS. Yeah, totally. Right. Any questions on this right now? I'd love to answer any questions or any kind of anything that you're not quite getting. We'll get to that in a minute, Jennifer. That's the even cooler part. Julie, still can't use arrow notation in this case, though. No, not right now. I don't want you using arrows for anything quite yet. Christopher, the constructor function is always called with the new keyword, okay? And that happened before, too. It was called with the new keyword, and it just so happened to be the function, right? So the new keyword is going to call the constructor. You don't ever have to call the constructor. Well, hold on. But it doesn't add the constructor is not, oh, let's see. I don't know if it's going to give it to us. No. I don't believe the constructor is on the prototype, but don't quote me on that. Well, we can look, actually. Let's do that. Fruit has already been declared. Ah, dang it. Okay. We're creating that fruit. Let's create this. Console log banana. If you want to see how it actually works, not just in Replit, we're going to see fruit. We're going to see geographical area of tropical, type of banana, and look at this proto object here. This is what the JavaScript interpreter uses to access the prototype. Open that, and now the constructor is on the prototype. Cool. Yeah, it is. Also, is a fruit is on the prototype. Also, needs heat is on the prototype. Also, what's on here on this prototype? That's an object prototype, right? So that's the parent of the fruit. So all the way up to object, right? And what's the parent of object? Is there a proto on here? It should be window, but yeah. Essentially, it's object. Okay, so that's how it accesses. So yeah, the constructor is on the prototype, but we don't really need to worry about that. We're never going to call the constructor. All right, any other questions of what's going on here? Look how easy it is to add classes now. It's really important to understand what each of these things is doing, okay? That's why we learn the pseudo-classical way of doing it first, because you have to understand what's happening in constructor. You have to understand that using new calls the constructor. Yeah, all right, totally. So let me go grab this gist and I'll bring it in here. Oh, I don't think it's gonna work. Okay. Let's create it right now. So that, remember, fruit, this is our old way of doing it, right? And we knew that if we called new on it, that it would call this function and it would return a new context of it. Same exact thing is happening here, but we're actually using the term constructor. Constructor is a term that you have to use, okay? That's not a made-up variable like everything else we do is. Constructor is very clearly, we have to use the word constructor, okay? There. Because it's going to expect there to be a constructor function. And then we pass it whatever we want, you know, like in our constructor, in this case, we have an object with a couple of key value pairs in it. And it's going to go and create that context for us. And it's going to pass that back to us, right? The same way as we did it before. I don't quite follow, Julie. It's helpful to see the const banana in the same area. Okay. Let's go do that. I mean, bring it up here like this. Cool. All right. So now we have our constructor. We've been writing constructors for the last 2 days, 3 days now. Now we've added a couple of items to our prototype as well, but instead of going out here, needs heat equal to function, etc., we can just write it right in line with our class, okay? And now we have access to it. Run, we have true. Not a function, okay? This, remember, this uses this keyword just like they would if you wrote them on the prototype. This is referring to that instance of the constructor, all right? So this is still referring to that instance of the fruit. Okay, so now we have our regular, we're doing nothing different down here. It's all the same. It's just the way we write our classes now. Any other questions? Till we get into the really cool stuff. All right. Let's create a child. How do we write our apple? What do we do? What do we write our apple in ES6 classes right now? First two words. Oh, there's more. It gets cooler. Class apple, right? Class is lowercase. Remember that. Apple. It's going to be uppercase. And what do we do? We have apple stuff, right? In our constructor, and then we did fruit.call this, and then apple stuff, and let's go down and grab all of this. All right, and let's create an apple. I was hoping I could do it. Okay. So in this case, we are not going to use fruit.call. All right. We don't have to, well, we do, but we're going to do a little bit of different syntax. If we are creating a child of a parent, we are extending or we are inheriting the parent's functionality, right? And so after the name of the class that we want to create, we can say extends fruit. okay? This is going to say apple is a child of fruit, all right? So now it's going to go up and grab fruit. And the constructor, we don't have to say fruit.call anymore. We're going to use a new keyword in our constructor. I think there's like 3 new keywords that we're going to have to remember with this syntax. Well, 4. Class, extends, constructor, and anyone know it? Yeah, super. So super, all right. Super calls the parent's constructor. That's all it does. All super is doing is going to say, what are we extending? Fruit. What's fruit's constructor right there? Super is going to essentially say fruit.call this apple stuff. That's what super is doing. It's going to pass in our context of this. It's going to call the constructor. It's going to get that stuff back, and it's going to create a this context. Okay? So just like here, instead, we don't have to do this anymore. We just pass in whatever our class's constructor takes. So we want it to be apple stuff, right? That's it. Now look. All right. Just remember these 2 lines here. Super calls the parent's constructor, and I want to say passing in the context automatically for us. Okay. Super calls the parent's constructor, passing in the context automatically. Automatically, it does it all for us. Dwayne, great question. What is fruit stuff right here? It's a variable we gave to the constructor. What is apple stuff right here? A variable we gave to Apple's constructor. It could be whatever, right? We can call this constructor stuff if we wanted to. It's that is not, I want to call it, yeah, I'll just call it constructor stuff. We don't have an idea of what fruit stuff is here. We don't really know. Okay. No, I want to give these different names then. It really, I'm going to get rid of that. I want you to understand that that doesn't matter what it's called right there. That doesn't matter what it's called. So we're going to go, oop, nope, don't want that. I'm going to go back to this because I don't want you to get hung up on what that is, right? Look at that. What's super passing in? The 2 items that the constructor expects, right? That's what it is. That's all it is. That's all it's passing in. Or whatever the constructor expects. And with super, we don't have to give it context, right? We don't have to do that because super calls a parent's constructor, passing in the context automatically. All right, so we only have to, in super now, give it whatever items it's the constructor is expecting. That's it. Just remember these 2 lines here. Essentially. Great question, Griffin. If we don't have extends, how does super know what to call? Right? We need to give it that extends so that we can say super is going to go, okay, this is a child of fruit, so I'm going to go call fruits constructor. Want to see something really crazy? That's really crazy. What does super also do? The coolest thing super does is it automatically links our prototypes. Okay? Automatically does it for us. We no longer have to do object.create. We no longer have to say apple.prototype equals object.create fruits.prototype. It automatically does it all for us. We automatically get that stuff now. Like I said, there is a lot of magic that goes on with class, the class keyword. There's a lot of magic that goes on with the super function. Understanding what's happening behind the scenes is going to take you a long way, okay, in really understanding what's happening, especially when we get to React, in any other advanced JavaScript stuff we do. Griffin, we are going to put whatever the constructor of what we're extending expects. So if it's expecting a type in a geo area, we're going to put the type in the geo area in super. Oop, someone unmuted themselves, please. Make sure you say muted. So whatever our constructor is expecting is what we're going to put into super. If it's not expecting anything, we don't have to put anything in there. We don't have to put the context. We don't have to say, please link our prototypes for us. We don't have to do anything. We should still capitalize the class name. Yes. Jess, that's what I love doing JavaScript for. That's why I love this lecture so much, because everyone's like, what? We could have been doing this the entire time? Yeah, you could have, but you would have had no idea what any of this was doing, right? You would have been like, cool, it does stuff that for me, and then it works. And that's what all you would have known. But now you know what it's doing and how it's working and behind the scenes. And so now look, all of this code, let's take this. We're going to add the is good in Pi. What's wrong with this right now? Yeah, we don't need that function keyword. Boom, boom. How straightforward and simple all this is. I mean, we can make it really small if we wanted to. All right. That's our class constructor and our prototype and our calling the parent prototype and linking our prototypes together. Apple One is coming from right there. No, it's not. That's not bad to do it on one line. You don't really need much beyond that one line, right? But if you want to make it more readable, that makes it a lot more readable. I'm just showing you how much less code we just wrote. I want to come back to this super thing because I think there's still some of you that are confused of what's going on. Okay. Yeah, this is, sorry, that's what's happening, right? That's what super is doing. And super is also doing that for us. It's doing both of those things for us. Okay. Kyle, that is a no-go right now in the classes. So no arrow functions for your prototype functions. Nope. There is when we get to React, you'll see there's some new stuff with classes. There's some ES8 stuff with classes, but we're not going to go there yet. Where we can use arrow functions. Many, we will use arrow functions in 4 weeks. I had to think about it. Christopher, extends might do it. I'm just saying that's what's happening. Extends might be extending our prototype. So yeah, that's probably true. Makes more sense. So the extends is actually creating our prototype for us, and the super is doing the call for us. Oh, there's ES7 as well. There's ES7, ES8. So let's talk about it. If we had a specific class, University of Minnesota is where all these apples come from, and we wanted to say U of M apples only, but they're all apples, right? How would we do that? Oh, that's where all the best apples come from, the University of Minnesota or Minnesota State or something. Extends apple, right? Yeah. Right? Have our constructor, if we can spell it right. We do a super on it, and what does super expect? I don't like that anymore. We're going to go not apple stuff anymore. We're going to do variety, color. Okay, expects a variety in color. And then we will just give it something on a prototype. It says created at University of Minnesota. Turn true. All right. And now we say Honeycrisp is not just an apple. It's a U of Minnesota apple. Okay. All that's still going to work, right? But now we can say, we're going to call this Honeycrisp. H-Crisp. Is created University of Minnesota. All three are true. Let's go in here and let's do a const G Smith, new apple, Granny Smith, green. And now let's come down here and say log G Smith dot created at University of Minnesota. Undefined. I have no idea. Right? No. All right. Well, there's only going to ever be a created at University of Minnesota on the University of Minnesota subclass, right? So we can never check that if it wasn't. That's probably a really bad example. We shouldn't just be returning true because we can just set that as a parameter. We can just, something else, if variety equals Honeycrisp, return true, something like that. Let's talk about defaults real quick. First of all, are there any questions about this? Look, HCrisp has the is a fruit, is good at MPI, created at University of Minnesota, and that's that's fruit, apple, and U of Minnesota, right? Classes, those 3 classes. And it has all 3 of them. And all we've done is extends and super, okay? And it's extended all of them. Let's do this. Okay. We're going to do this. All right. Show you what's going on here. All right, let's see. We've got a question about defaults. Any other questions right now about class ES6 class syntax? What's going on with the class keyword, extends, the super keyword, what it means? Any of those questions right now? I'm sure all of you are very happy with seeing this and seeing how simple it is to do all this now. You don't have to remember 45 different steps anymore. But it's important to understand what's happening in those steps. All right. So let's talk about default properties. I'm going to talk about this very shortly. This is not a necessity. ES6 has the concept of default properties. So we say, says hi. And we can say friend, right? Let's just do all of our stuff we did before. And we're going to console log hi. Oh. Hi and friend. Pretty simple. Oh, hi. Okay. Pretty simple, right? Everyone knows how to write a function. Everyone knows how to pass an argument and use a parameter in a function. What if I did this? I would get hi undefined, right? Hi undefined. Well, how do I make sure that friend is never undefined? ES6 or 7 introduced us to something called default properties, or default parameters, excuse me. So default parameter, we can say we're going to take a parameter called friend, and we're going to say if there's nothing, we're going to make it Dan. And now we get hi Dan. And you'd be like, well, isn't that always going to be Dan then? Kyle, you're on first on my list. Nope. If it's undefined, it'll set it to something. If it's defined, it'll set it to something else. Okay? Then we can say friend 2 equals a Look at that. Okay. So it's just going to make sure that it's not defined. It's not ever undefined. But if we do, there we go. Okay. This is known as a default property. Okay, I don't want you to get too hung up on this because this is not part of the lecture tonight, but you can also use default properties in your constructors. So if we don't give it a variety, we can just say variety is red delicious, right? And then if we don't give it a variety for some reason, it'll just give it red delicious as the variety. That's it. Okay. So we can use default properties in our constructors, but you are not going to be expected to use default properties in the assignment. I just wanted to let you know that that exists. Okay. Any questions about anything tonight? Sure. Corey, yeah, you can do that. And it would just be an empty string instead of undefined. All right. Ooh. That's all it is. Let's get some questions. I want some questions, and then we're going to take a break, and then you're going to start working on your JavaScript 4. Ryan, can't do it. Unless you say undefined. Like that. You can do that, but that's really not really something you would do. You would set default properties. You tend to set default properties on items that you know are optional. Okay, and that's just getting into a whole different can of worms there. I wanted to bring it up because I said I would tonight, but I don't want you to focus on that. I want you to focus on class syntax. If you are interested in default properties later, default parameters, excuse me, not properties. I don't know why I said that. There is a resource for you. Okay. Julian, no, because if you passed an underscore to skip a param, well, then you would need to understand that the parameter exists. So, I mean, underscore would have to equal something. When you pass an object to the constructor, is there a way to know what properties the object needs to complete the constructor? You'd have to look into how the constructor was using that object. If you saw something like this, and it was just saying right now, some unknown object variety, object color, then you would know that it needed a variety and a color. Okay. IntelliSense works if you're using VS Code or VS or WebStorm, but that's the only way you would know. You'd have to look into the constructor and see how it's being used. All right, that's how you would know. Any other questions right now? I hope that this is a great evening and a great lecture, especially considering all the work you've put in the last couple of days with learning classes and prototypal inheritance. Cool. Well, everyone, I'm going to post this up on that gist, and I will get rid of that. You have access to that if you want it. And that. And we're going to, I haven't pulled up the assignment yet. 4. Paul, yes, you can use the type of keyword. So you can say something like banana type of, ooh, it's object. You're gonna have to look at the actual syntax. Wait, 56. I don't see why it's doing that. But you can use type of, or you can use instance of, or you can use the constructor. So I can say banana dot constructor. And it's going to give me class fruit. There's a lot of different things you can do to check the type. All right, everyone. Have a great night. Get working on that. JavaScript 3, you'll go over together with your peer review group. Should have gone over it last night with your PM stand-up group as well. If you have any questions about that, post it in the help channel. Any questions about tonight, post in the help channel. DM your PM, DM me if you're really stuck, and I'll post this just up for everyone. Have a good night, everyone, and enjoy working on this lesson tonight. See ya.